So my name is Dave Mexicott. I've been with Cisco about 13 years, and some of you will hear the same jokes from this morning, but I have been doing wireless since the mid-'80s, which is why I have no hair. So when these technologies first came out, FCC Class 15 first came into the market, we started doing vehicle telemetry and a few other things with those types of technologies in these unlicensed bands. What I want to talk about today is very quickly, in about 15 minutes or so, kind of go through why doing wireless for iPads in a BYOD environment is different than doing wireless that we've done in the past. Things have really changed, and it's because of the densities that we are starting to see now. I always like to use this slide. This was a university put together about, it's getting close to 4 years now, 400 seats in that auditorium. Now, when that wireless engineer put this together, what was the absolute worst case scenario for that room? It was 400 devices, wasn't it? Now, how many devices do you think are in that room? At least 8, right? And I see this time after time after time. The number of devices that are going into the networks have skyrocketed. Now, let me ask you this. How many of you replace your APs every year? Very few of you, right? None of you. I don't know why I even bothered to come down here. I was hoping you guys would replace your APs every year. The thing that you have to plan for when you put this network in place is that this has to last, on an average, for about 5 to 7 years, right? So is the number of devices going to go up in 5 to 7 years? You can bet it is, right? We see this with universities. I told this story earlier. I had a university, this was now 2 years ago. September rolls around. They were planning for 10,000 concurrent connections, wireless connections to their network. Guess how many they got? Don't you guys answer. They got 70,000. They underestimated by a factor of 70. So this problem keeps getting worse and worse. Now, what's interesting from a school perspective, now when you send your kids off to college, this is what they're saying now, right? Yeah. Is that Wi-Fi is more important than beer, and where are their values, right? But it's become very, very important. We've been dealing a lot with Hurricane Sandy, actually in New York, and it is amazing when people tell us the withdrawal they've had from being internet connected. It has totally changed the world, and kids expect this. Now, the big thing that's happening is that now we are moving curriculum onto these devices, and we are moving learning onto these devices. And that's very different. Because in the past, what we used to be able to say, if someone was having problems with connectivity, well, just plug in, right? Well, how many RJ45 jacks on one of these things? 0, right? The world has changed. Wi-Fi is now our new physical layer that we are going to deliver curriculum over. The other thing that has changed is in the education market, and I've been doing education for quite a while, but in education, we used to be, we weren't nearly as technology savvy as the Eli Lillys and the Fords and so on. Those were the guys who were really driving technology. But in BYOD, it is you guys that are driving the technology. Businesses do not see the types of volume and the number of devices that you guys see. You are the worst case scenario. Doesn't that make you feel better? The types of devices that are coming to your environment, the densities that you have to deal with. Business never has to deal with this type of density. You have far higher densities. So the APs that we build today will actually accept 200 concurrent connections per radio, actually. Now, I never want you to design to that. But the reason why we do that is an AP has to have the ability to manage those connections. The number one determiner of how many connections an AP can handle has nothing to do with the speed. It has to do with the CPU and the memory architecture of that AP. Right, we've all seen this with like a Linksys, right? You had a Linksys 54 meg AP, and you can get about 10 concurrent connections. But an enterprise grade AP has the ability to have 100 different encryption keys and switch between all of them and talk to all those students that it's connected to. It's a very, very different type of situation that we have. Now, Cisco, the unique thing is we are an RF design company. We have RF engineering. Very few people in this industry do. They buy their APs from the same vendors. Most of them are from a company by the name of Acton. and all the intellectual property they have is on their controllers. We actually do RF engineering. And when we bring these devices into our RF lab, which is in the Akron, Ohio area, and test them, the first thing that we find out is that they're pretty lousy Wi-Fi clients. Have you noticed that? These are not the same quality Wi-Fi clients as the PCs that we used to design with. When we first put our Wi-Fi networks in place, we had a device with a very robust Wi-Fi connection, and we had big cells. Now we have devices that have a much smaller footprint. And it's not because they're bad devices. I've got a device like this, I'm holding it against my head. My head has water in it. It actually blocks the RF signal. So the footprint of these devices that we're now going to move curriculum onto is about 1/16th. 1/16th that what we were used to designing networks for. It's a huge difference, right? So the way we design networks has to change. In fact, this is why Gartner has been telling their customers that you're going to need 300% more APs to do BYOD. Now the reality is, if you've been doing Cisco type design, what we've been recommending over the past few years, that won't affect you. But if you've been trying to do coverage, get the sparsest coverage you possibly can, it will affect you. And you will have to add a lot more APs. Just some more looks of that. This is one of my favorite slides. I showed this one earlier today. The other big thing that you have on BYOD is a security aspect. Because think about this. You are now relying on that end user to establish endpoint security for you if you don't have a system that is controlling that. And the worst case scenario is these codes, these are the top 10 4-digit unlock codes that are used on iPhones, iPads, tablets, and so on, right? And I'll always say I'll pause for a moment while you check to see if yours is up there, right? It's because they're easy to get to. The thing is, these are known quantities, right? So a student, just by picking up a tablet, a device, a phone, and trying out, if you have a 4-digit code on it, they'll try these codes. If they try all 10 of these codes, they have a 1 out of 7 chance of getting into that device. 1 out of 7. Now, is that a plausible scenario in the 5-year, 7-year lifespan of this network? You bet, right? So what if the teachers use that device to access a grading system, and the browser has cached the credentials? You now have a vector into the grading system that you would have never accounted for. So we also have to now start to move security up into the network to a point where you can actually control it. We have to get control of our endpoints. The most important thing, in BYOD is it is not about the software or anything that's on the controllers. It is a raw RF issue. You have to have very, very stable RF to be able to do this. And it's because RF is a mess in a normal building. I mean, this is a hard building to cover. Look at all the steel in this building, right? Some of you, I was talking to some of you guys, you had old buildings, some of them are 80 years old, that have thick masonry walls. The worst building I've ever done is actually a castle in Luxembourg that had stone walls built in the 1500s. We needed a 5-foot drill bit, to be able to pull wireless in it. It's actually part of University of Miami, by the way. They own that facility. But it's very difficult to get RF into these buildings. Now the old way we did it is, let's just throw a few APs up, let's dial them up to 100% of the power, let's paint the space with RF, right? Let's see if we can cook a hot dog as you walk through the building, right? But the problem with this is, in BYOD, the issue is not hearing the AP. The issue is the AP hearing the client. And you have to change the way you think when you're talking BYOD. Because we now have more devices creating more noise, we're getting farther away from the AP. And the whole trick to this, to being successful in BYOD, is for this client at the edge to stay connected at a high data rate. When clients get out at the edge, they drop their data rate. When an AP can't hear a client keeps speaking up, trying to get access to the medium. And how all the other devices around there, and we were discussing this problem earlier today, how every other client reacts to that is they dial their data rate down to try to get to a better level. And I see this happen time after time. We were discussing a problem earlier where a whole bunch of people come into a room and they connect to an AP and everything looks fine, but as the day goes down, it gets worse and worse and worse and they have to reboot the AP. What's happening? What's happening is all the clients are reacting to noise and they're dropping their data rates to the point that it gets to be unusable. So you have to be able to control that, and that's what the Cisco system does, very, very well. It's designed to do that. The other issue that you guys have in BYOD, once you fully populate this, guess what? The number of devices per AP goes up roughly with the square of the distance. So if all of a sudden you try to save money and get your APs to cover twice the distance, that AP now has to handle 4 times the number of clients, right? It's an engineering problem. It's not sustainable. So NSI, has the ability to come in and look in your environment, actually help you set that up, help you with the proper AP placement so these algorithms that are built into the system work, and things work a lot better. I probably should just skip this, but this just talks about how much bandwidth we actually need to be able to do these kind of things. It's important not to underplan, but it's also important not to overplan. I mean, I love it if you plan on 5 megabit stream to every kid, because we'll sell a lot of APs. But the reality is, you're typically going to be kind of in these levels of what you need to do instruction over this. I'll skip this a little bit. Guest access is extremely important in these environments. As a parent, I know I wanted this when my kids were actually going to school. Very easy to implement guest access is available on it, all the way to the point that you can actually just say, I flip open my laptop and I say I want guest access, and the system says to the parent or whoever's requesting, what's your cell phone number? And you put your cell phone number in, and a text message comes back to the cell phone with unique credentials to get on the network that are timed and get shut off after 4 hours. The reason why that's important is systems where a parent has to check in to get the code of the week, code of the day, code of the month, they don't work, right? Systems where they call you and ask for temporary credentials, they don't work. You have to automate these systems in a BYOD environment because the number of clients is absolutely daunting that you have to deal with. Make sense? Okay. On the Cisco, very quickly, Paul talked about this, the new Cisco Prime. It is awesome. WCS was awesome. The old stuff that we used to manage our LANs was terrible. Cisco Works. And that whole group, we realized WCS is the best management product we have. Why don't we start to use that to manage the network? And it's great timing, because even companies like Gartner are now looking at your networks as a whole. They're not looking at a separate switch versus Wi-Fi. It is called access, unified access. How do you come into the network? And you need to have a view of that. So with Prime, you can do things like not only troubleshoot clients that I talked about this morning, but you can do end-to-end troubleshooting, because that's going to become a bigger issue. If I'm watching video, it might not be a Wi-Fi issue why my video stinks, right? It might be a switch that video moved through that has improper quality of service. I've actually seen this. I had a customer complaining about their Wi-Fi. Their Wi-Fi doesn't work. Kids can't authenticate. Well, the way their Wi-Fi worked is they were all going to a web server to authenticate, and they had a bottleneck to that web server. Had absolutely nothing to do with the Wi-Fi, but yet it was impacting students that were using the Wi-Fi. These tools will allow you to actually, work your way through that. You can see where devices are in your network. You can actually dig into a client and see what kind of experience it's having over time. You can troubleshoot it, and the system will come back and tell you specifically what the issue is. In this instance, it's a radius server. Now, if your superintendent of schools is yelling at you that they can't get on the Wi-Fi, would you start by going to look at your radius server? None of us would, right? That's hour 4, right? The idea behind this is let's narrow down time to resolution. And I have universities and schools that have implemented this system, and it definitely lowers the amount of time it takes to address and deal with problems. Applications, controlling applications in your environment. How do you know your bandwidth isn't being taken up with things you don't want on there? We can actually look in and see the applications to a very deep level, because this is based on NBAR, a technology we've had for years, and actually, BitTorrent and so on. We can actually have it shut down. Or if you're delivering curriculum, we can identify the protocols that are being used for that, and we can give those prioritization, making sure that that always runs well. If you're running Citrix in your environment, we can always give that prioritization. And things like YouTube that are going out, we can give lower type priorities to it in a very, very easy fashion. Lastly, in Prime, one of my favorite features is who's ever opened a TAC case, right? One of the neat things in Prime, if you go to the device you're working on, and say, I want to open a TAC case, you can open the TAC case right there in Prime. And Prime will go out and grab all the logs and configurations off that device and stuff it into the TAC case before you've ever talked to an engineer. So on a day-to-day operations basis, we're trying to make your life easier by adding more and more into this tool. And Prime will also help you manage other devices, non-Cisco devices in your environment. It's an SNMP type manager, and depending on what your device will support, we can actually bring that up into Prime and you'll have visibility to that also. Questions, comments? Probably the neatest thing is there's an iPhone app so you can screw your network up from home, right? It's actually, you know, we want to see, we want to know what's going on, right? That's why it's cool to have an iPhone app, so you can actually see what's going on in your environment and be connected all the time. Bonjour Gateway built into the product. Security aspects with a new product called ICE, where we can actually do onboarding, give you a single pane of glass for all your authentication needs in your environment. Some schools go for this, some hold off, but the beauty of it is it's extensible, so it's something that you can plug in later on when you need it. So you might have an application where if you're going to allow a teacher to bring in their own iPad, you want to control that, right? So the teacher brings that in, connects to the Wi-Fi, it gets identified as a teacher because they enter credentials. A certificate gets put on that device so we can protect it and identify it in the future, and they get routed to anywhere in the network that you want them to be. It gets controlled. Whereas students, if they joined with that same type of device, because it hadn't been identified as being owned or having that type of access, they would only get pushed out to areas that would be student contact. So ICE is going to be a very, very big aspect of it. Clean air, I talked about this earlier today. Because the environment that you're in has so much junk, right? This is all the junk that the FCC allows to be sitting in those spaces that you're going to be delivering curriculum over. All of these devices here, all of these frequencies can actually bring down your Wi-Fi and destroy that experience. So Clean Air is actually looking for this and will identify it. And we'll find all these interfering devices in your environment. And no one else can do this. They'll tell you they can, but they can't. They can't discriminate between all these devices. And it's important because these devices are excellent jammers. Look at these video cameras, right? They will jam 100% of the Wi-Fi in the area. What if Joey decides he doesn't want to take a test today, right? This thing snaps on top of a 9-volt battery. Can have it in his pocket, snap it on the 9-volt battery. No test today. Plausible scenario in the 3 to 5 to 7 year lifespan of this network, right? So this makes your network self-defending. We will actually move channels immediately, sub-second time frames, around that interferer and tell you that you have a video camera in room 101. It is very, very specific what it's going to tell you, and that is actionable because you can go into room 101 and say, there's a video camera in here somewhere, and you can do something about it. Every other system on the planet is just a check engine light. It'll just say, problem in the west wing. Go figure it out, right? Don't you love a check engine light, right? It either means your EGR valve is failing or your wheel's about to fall off, right? I mean, it's too big a scope for you to be able to act on it. So it gives you a very, very narrow aspect of what you have to actually see. The last technology I'm going to talk about is a beamforming technology that we have in our APs called ClientLink that will actually determine when someone gets into a bad area and will steer a beam out to them and present them a higher signal strength. And the reason why we do this is when someone gets out at the edge, they drop down to a low data rate, right? And that impacts our network. It's better to have 50 guys connected at 300 megabits than it is 50 guys at 1 megabit, right? So we want to keep everyone up in the high data rates. And essentially, it fills in all the holes in your network, and it is dramatic. One of the first customers I did this with was a steel mill. They had a guy at an overhead crane. It was a terrible Wi-Fi environment, and they had a guy at an overhead crane with a 300-ton ladle of molten iron, and evidently want to give him the ability to browse the web while he's doing it, right? So it's something that you have to be able to deal with on the RF layer, and that's what ClientLink does for you. It smooths that out. It holds people up into the high data rates. It gives every device in your network better performance, and it actually gives those devices better battery life. And it's dramatic with devices like iPads, where all of a sudden now they're not allowed to drop into low data rates. They're held into a high data rate where it's more efficient battery life usage, and now the battery life usages of the iPads throughout the school are more or less the same, rather than some kids having bad battery life and other kids having good battery life. All right, that's the essentials of the Cisco system. I'm going to stop there, Paul, and we'll talk about getting curriculum onto this.